Well, let's continue talking about graphing or quadratic inequalities, and we're um, now going to talk about solving them by graphing. And so here we've got solve ax squared plus bx plus c being less than or equal to 0. Or I could say that 0 is greater than or equal to ax squared plus bx plus c. Is actually the way I would prefer to write it because it puts it in that y equal, y greater than, y less than form. And ax squared plus bx plus c is just standard form for a quadratic equation. And where in the previous video we just established where the regions were, this time we're going to actually solve for what the values of x are. So we've got an equation here. 0 is greater than or equal to x squared plus 5x minus 6. And here in just a moment, I am going to graph this. And I'm going to substitute y for 0. And we're going to graph it as greater than x squared plus 5x minus 6. Now I'm going to already give you the solution, and then we'll confirm that when I go to the graphing calculator, because I'm going to graph this on the TI-84. So the solution of this is, and we're going to see, and that x-axis is going to serve as a number line for us, if you will, that our domain is x such that -6 is less than x, or we could say that x is greater than -6, and it's an and statement, and x is less than 1. So let's move to the calculator. We're going to graph this. I just want to go over once again how we could graph an inequality. And then we'll see the graph and see how that confirms this solution that we have here. And again, I'm going to substitute, there's our solution, and I'm going to substitute y for 0. Okay, because we're finding the zeros of this inequality, actually, is what we're doing. All right, I'm over here on the calculator, and if you recall, our equation is going to be, after I substitute y for 0, that y is greater than x squared plus 5x minus 6. So I'm using the inequality app, and I'm going to move my cursor here, and I'm going to highlight that whole equation, and I'm going to hit enter. And I'm going to change this from an equal sign to a greater than sign. And you notice it should give me a dashed line for my boundary line. I'm going to hit enter and enter again. So there, I got that part done. And now we've got x squared plus 5x minus 6. And let's go see what our graph looks like. Okay, so you can see that it shaded our region for us. I got a dashed boundary line. And let's see, got -1, -2, -3, -4, -5, -6. So here's -6. This x-axis is serving like a number line for us. So that when x is greater than -6, but less than 1, here's my boundary line on the right along the x-axis, that is part of my solution set. And so it's an and statement. It's the intersection of the various solutions, and I can see that proves out there on my calculator. All right, we're going to do one more. And this time I'm going to already have graphed it for us, and we're going to establish our solution set. All right, so here we are, and my inequality statement was -x squared plus 3x plus 10 is less than or equal to 0. And I actually changed this around, if you will, as far as what I graphed, to y is greater than or equal to -x squared plus 3x plus 10. And that's what you see over here on the right in this graph. And of course, my shaded region is outside the boundary. In this case, I've got a solid line for a boundary because it's a greater than or equal to. And so what is our solution set? Well, I see that once x is less than -2, that's all part of my solution set. And I also see that when x is greater than 1, 2, 3, 4, 5, when it's greater than 5, well, that's part of my solution set. But between -2 and 5, that's not part of my solution set. So I would then say that my solution set is, I think I can do it right here. Yeah, that's not going to show up real well. Maybe I can put it down here at the bottom. Yeah, that's a little bit better. X such that x is, I hit the color, x such that x is less than or equal to -2, and this is an or statement, so it's the union of the two solution sets, or x is greater than or equal to 5. And I can see that being borne out by what I see there on the graph. It's kind of fun.